Hi, welcome to LinuxFest NorthWest 2020. My name is Chris Vantine, Chief Technologist for the West Coast at Red Hat. And today's talk is about continuous security with Kubernetes. If you have any questions or comments, feel free to reach out at my contact info below. Andy Grove back in the 90s talked about only the paranoid survive. And this is about strategic inflection points. And at the time, shortly after the Pentium bug, Andy talked about how companies have points in time when there's maybe a lot of disruption technology-wise or new competitors, and the company has to decide, do they stay the course or pivot and change? Could be a matter of survival or thriving. And certainly the Pentium bug was a key point in time for them. They had pivoted in marketing directly to the consumer. And initially, they didn't do a recall for the Pentium bug, but they realized that because they're marketing to the consumer, they had to behave differently and they had to pivot their approach. And certainly, when it comes to security, there's a movement in shifting how they approach security in IT. DevSecOps is a big transition in terms of how IT is approaching security because traditionally, security has been an afterthought. It's when I first joined Red Hat, I would talk about companies who would say, hey, we hide our servers behind the firewall. We manage security by firewall. And that simply is certainly not enough today, especially as applications get broken up into microservices. And now they're spanning on-premise and off-premise, right? The network is increasingly becoming more and more important as one microservice talks to another via API. And multi-cloud, right? Running your production workloads, sometimes developments in public cloud and production on-prem, on virtual physical infrastructure. And so the thought that you can surround a secure perimeter around your servers is no longer the case, right? It's breaking down. And certainly the expectation is that VMs and containers live side by side. In the days of your own dedicated hardware simply cannot persist in a cost-effective manner. So multi-tenancy is a key security design principle, and especially around containers, ensuring that enterprise applications are secure. So the evolution of DevSecOps is about inserting security within the culture, in the process, and the technology. Right? From a cultural perspective, prioritizing security and product development, integrating into your development practice, integrating into the processes, your continuous integration, continuous delivery pipeline, and we'll talk more about how in this presentation. And then leveraging tooling to make it simple and automated as well. And so some of the benefits and the approaches are certainly DevSecOps is all about reducing business risk, and many of the customers I talk about, that's one of their top risks in their 10K. And also about lowering the cost, right? We don't want to overburden the developers. We want to enable them to move quickly and focus. And then we want to be able to react and speed up the delivery when there is an issue so that we minimize downtime, we minimize the exposure. And this can all be done through automation, process automation, and continuously improving, having that process in place within your organization. So how to manage DevOps at scale is Kubernetes is increasingly not only seen as an orchestration platform, of course, across multiple providers, but also you can define security policy, and the security tooling and configuration can be consistent across those providers because it's providing a level of abstraction. Right now, I don't have to cater my security policy or tooling to a specific provider. I can simplify by having one way, making it easier to configure, easier to comply with my security requirements. And also, I can deploy my infrastructure wherever it's needed to meet security compliance standards and regulations. So some of the best practices around securing containers are, one is to take a layered security approach, right? No one technology or configuration is going to solve all security problems. You know, the days of the firewall being the one way of securing your infrastructure are long gone. And taking an approach of least privilege, right? Only giving out what is necessary. And also reducing the attack surface, right? By minimizing what's in your image, right? Only build an image of the essential components. And then making it immutable, right? Build it once, deploy anywhere. If it needs to be updated, you don't log in, you go back to development, build version N+1. So first off, we'll talk about container images. You know, they enable DevSecOps because for exactly that. They allow you to define a recipe of how the container image should look like. So infrastructure as code, or in this case, application as code. And it allows you to share that image once it's built in a public or private registry. And then I can take that image and deploy it on a standardized runtime that's consistent across all my providers.
Now, the container image from a developer perspective is a transition from a developer providing just a jar file to a container image. And that container image consists of multiple layers. You have typically a base image that the application runtimes would then be layered on top, as well as the application. And these images can be tagged with a version, so you can have multiple versions as well. They can live side by side on your server. And then also, one of the key things around containers is to treat them as immutable, right? The container image with those 3 layers, what do you do in terms of configuration and data? Because the image itself, you build once and then you never change. If you need to, you go back and create the next version. So Kubernetes provides the ability to configure the host upon launch into a container instance by using a resource called a config app or a secret. Right? The config map allows you to define a key value pair, such as a username or IP address or a configuration file, and inject it into the container instance when it's created in a Kubernetes cluster. Now, you can also access remote data services or mount persistent volumes as well when you launch the container instance. And so that allows you to keep the container image as immutable and treat any changing data as a config map or secret if it needs to be encrypted, or stored on a persistent volume or remote data service. Now, the config map could be a configuration file, like an XML file for JBoss. And I could version control that, keep that in my GitHub repository. And then when I deploy my Kubernetes application, I can define that application as having a config map, which is mapped to that text file. And then when I create the instance in the cluster, Kubernetes will create the container in the pod, and then it'll mount any volumes I specify, but also mount any config map. And that config map could be a file, or it could be set as an environment variable. And so that's very useful for applications that have configurations, because I can keep those separate and version controlled in my Git repository along with my code. Now, secrets are a special type of resource in Kubernetes that allows you to store things like passwords or SSH keys or certificates. And the difference between this and a config map really essentially is that it's encrypted, both in transit, and then you can enable encryption at rest. And these are stored in the etcd distributed data store as a key value pair in that uh, data service within the Kubernetes infrastructure. Now, when it comes to build files to define your container, best practices, treat the build file as a blueprint, right? This should be your recipe, version controlled in Git. You do not log into images or instances and make changes and save that image. Instead, make the change in the build file so it's reproducible, and you version control that. But make sure you're being explicit with the versions, not just using latest when you're pulling in particular components or using a particular image. And then always make sure you're specifying the full qualified domain name of the image registry you're pulling from. So here, registry.redhat.com/rel7, for instance. And then from an efficiency perspective, be aware that any run statement in the build file will create a new layer. So that creates complexity and inefficiency for your image. And then also, we don't want to run our container images as root, but that is the default. So you need to specify a user, as is highlighted here in the example build file. Now, another best practice also is to make sure you're signing your images, so then you can validate if it's a trusted source that your image is before running it in the Kubernetes cluster as well. Continuous builds. So when it comes to security breaches, sometimes attacks are taking place within the build environment, right? Injecting some sort of vulnerability into the build environment, into the resulting binaries, so that it can be exploited, for instance. And one of the ways to address this in a containerized environment is to have your source code and version control, but then leverage a container image for your build environment. And this container image would have all the build tools, and it would be leveraged to build your source code and then output a container image with your build application and all of its dependencies. And by having these version controlled, now I know that, for instance, version 3.1 of my container image was built using the build environment of version 101 in this case. And so now I can go back in the future, and then also I can ensure that the integrity of my build environment has been compromised. So a good way to ensure that I can reproduce my builds and keep my build environment secure. Now, once I have that application deployed out in production, I, as a developer, am really responsible for the application layer. But the application may depend on application runtime and then OS dependencies. And you can monitor the registry to see if there are any updates to these layers that you depend upon, and you could trigger an automated rebuild. So a good practice, monitor your registry for any updates that you depend on, and then trigger a new pipeline to automatically generate a new version of your application with those, for in this case, maybe patch vulnerabilities at the base image level of the operating system or the application runtimes. Next, we have the container registry and best practices around scanning. So what's inside the container matters, right? So as you build a container image, it pulls in all the dependencies. Here you have a C, Java application, and in the second column there's a Java. It pulls in the JRE. Over 60 vulnerabilities are been identified since the initial release. So you want to be able to monitor these on an ongoing basis and have a process around that. But you also want to make sure that where you're pulling images are from a trusted source. And so most folks are setting up a private registry on-prem or at a hosted, but allows you to keep track and provide access on a restricted basis and have a version history so you can go back in time. And if it's on a public repository, you may not have control over having access to old versions. And another best practice is to integrate a security scan into your continuous integration pipeline. So here we added a phase called security, and you could simply run a scanner to scan your environment. And so a lot of scanners are out there, but OpenSCAP is an open source one, which you may want to leverage, which will identify known vulnerabilities in your image. And then also, you can define a security policy, such as password, minimum password length, et cetera, and then it'll scan to make sure that your image conforms with that and generates a report from an audit perspective. So a lot of nice benefits to integrating that into your CI/CD pipeline in an automated way. Now, once you have your application built, you would want to actually deploy that out into your production environment. And so this just shows you typical CI/CD pipeline of going through the build process, putting it in a registry, pushing that from dev to test, and then ultimately you promote it up to production environment. And Kubernetes provides logical environments through network namespaces to separate logically the dev, test, and in this case, production is a separate cluster. But that allows you to share the infrastructure from a physical perspective, but have logical separation and security around that. And so once it comes to deployment, you may want to leverage some of the automated deployment strategies in Kubernetes, such as recreate, which allows you to kind of replace an existing cluster with a new version. Secondly, rolling update to gradually roll out a new version, replacing one pod at a time. The benefit over this over recreate is there's no downtime. And then blue-green allows you to kind of leave the existing environment totally alone and just route the traffic to your green environment. And therefore, if there's an issue, you can quickly revert back to blue and it's untouched, so you can go back with a high degree of confidence and low risk. And then also, A/B testing. You have a new security patch, you want to try it out on a subset of your traffic. A/B testing with canaries in Kubernetes allows you to do that as well. So a lot of nice deployment strategies that help you automate so that you don't have to write these yourself. And so when it comes to DevSecOps, some metrics you may want to track from a security perspective are around compliance score with the scanning tool. You also want to track the frequency you're deploying, the lead time to update your environment once it's a known issue. What's the failure rate of your deployments? And how long does it take you to recover when there is a failure? And of course, service availability. Now, from an infrastructure perspective, Kubernetes provides a lot of nice security capabilities. Here's a look at the overall architecture of a general security Kubernetes deployment. You have the API UI and CLI as interfaces into the API service, and then your configuration stored on etcd and all the resources within Kubernetes. And then you have a scheduler and a controller, which are maintaining the schedulers deploying and creating the pods out in your cluster, and then the controller is making sure that the declarative state is maintained within your cluster. And then of course, then you have all your nodes scaling up and down. But what you don't get is a lot of essential and necessary components such as management, monitoring, log, security, registry, storage, network, DNS, Linux, in your container runtime, right? And so when you think about it from a security perspective, out of the box, I don't have everything included and I don't have it all configured in the most secure way. So some of the things that take into consideration there. And also from an architectural perspective, here's just some different things if you want to optimize for it and focus on security. You may want to do one cluster per app, or based on a particular data set, isolate that from others. Or maybe it's based on location, right? So your Canadian customers, you have its own cluster in Canada, right? So it really depends on your compliance and security standards. Those are what we're seeing some of the customers do. You can also optimize for many other different things and different approaches to meet those. And then from a network perspective, traditional three-tier model, DMZ, internal, and database tier, and it gets more restrictive as you go from DMZ down to the database. Well, how do you map that to a Kubernetes environment, which is really a flat logical network model where everyone can talk to each other? Well, what you can do is typically you may have one cluster per zone. So typically your DMZ is not Kubernetes, but your application and your database tier. And so you may have a Kubernetes cluster per zone. Second way is having a shared cluster across multiple zones. And then thirdly is to kind of isolate particular nodes in the cluster to particular applications based on what zone they're in. All right, so this allows you to have a shared cluster, but my applications only run on application nodes in the cluster, and I can use labels and selectors in the scheduler to make that happen and have that separation. Right? And so that's a little less efficient, but it does provide some security in that for some customers who want to have that separation at the node level of their applications and the data. And then, of course, network namespaces. That provides this logical separation, as I mentioned, but also provides multi-tenancy of your applications. And SC Linux is a key part of that's complementary to that, as well as network policy, right? So you can leverage Kubernetes network policy to define or restrict access. So in here, you could say, hey, all pods in namespace project A allow traffic from any other pods in the same namespace. And you can define that in YAML within Kubernetes and version control that and deploy it across your environment. There's also pod security policies. So these are cluster level, and they're implemented as the emission controller. So basically, defining the policy for the pods, and then the emission controller makes sure that the deployment meets all those standards. And if it doesn't, then it rejects the scheduling of that, for instance. And so we mentioned an emission controller. What is that? Well, that's a concept in Kubernetes, which allows a API request to come in, and first thing from a security perspective is it authenticates that request, and then it checks to make sure it's authorized using the role-based access control. And then there's the emission controller, which can allow or modify that request, right, before it applies that update to etcd, and the controller will pick that up and then try to rectify the state in the cluster. Now, another key part around security is to have some sort of monitoring so you have feedback, right? So traditional host or container or host level metrics, those are provided with the node exporter, but also, the container, you get some stats there with the kubelet CAdvisor. Kubernetes as a control plane has some capabilities you can install popular to use Prometheus and Grafana for dashboards. And then also, as you move to microservices, you may want to adopt a service mesh and use something like Jaeger to do distributed tracing. So you can see bottlenecks, but also, you know, the service mesh can help you from a security perspective because not only does it offer mutual TLS from service to service, but it also can help you with like DDoS attacks because you could say, hey, if a service is not responding, give up after 3 tries so that you don't overwhelm the application and bring it entirely down. And another key component of security, mentioned that Linux isn't included in Kubernetes, but it's an essential part, of course. And Linux itself has some key capabilities and technologies to help you secure. And so a lot of these are not enabled by default, but you want to make sure in your Kubernetes environment you're taking full advantage of things like C groups, right? That's what provides resource limits and process isolation from a resource consumption perspective, so it doesn't, you don't have a noisy neighbor problem. And then namespaces, we mentioned there's network namespaces, and we're seeing user namespaces so that root user in a container is not root at the host. So if you breach a container and get to the kernel at the host, you don't necessarily have access to all the other containers or the host on that system. There's also SE Linux, which provides mandatory access control and locks down your process from accessing and restricting what it can access to an allow list, and its default is to deny all. Seccomp filters, that provides the ability to limit the system calls that your container has permission, and that way you can restrict what it can call the kernel. Therefore, you're not exposed to unnecessary vulnerabilities of unused and unneeded system calls. And then Linux capabilities, right? So you can restrict root level type user to limit the capabilities. So just another extra measure. And then, of course, read-only mounts, so that you're mounting file systems that are read-only and limit the exposure of and risk to making changes. When it comes to the Kubernetes node, just some best practices here. Don't run as root. If you must, limit the Linux capabilities, limit SSH access, use namespaces, and user namespaces is becoming more prevalent, more mature. And then also define resource quotas, enable logging, apply security routing, not just to the container image in the CI/CD process, but also at the host level. And we mentioned security context or seccomp filters, and then make sure you're running production unprivileged containers as read-only if possible. Podman is a runtime along with Cryo that allows you to run as read-only. So what's next? Right? There's other things around Kubernetes ecosystem you may want to pay attention to, such as virtual machines are being added. So I have a single control plane for containers and VMs. That's the KubeVirt project. A lot of automation on day 2 operations can be enabled through the operator framework, and that's a great way to automate data services that run on top of Kubernetes. And then also serverless, right? Being able to have event-driven running of containers that scale from 0 to infinity, essentially, and back down on a on-demand basis triggered by events. So file gets uploaded, perform the transformation from one format to another, and then when it's done, stop running. Also, service mesh, right? We talked a little bit about that. Istio is a popular option, mutual TLS, service to service, and then traffic routing, shadowing traffic for testing, improving testing as well. And then CI/CD, so defining CI/CD pipelines in a Kubernetes native way. Tecton is a nice project around that. So that's all I had today. I want to thank you very much for attending today's session. Again, feel free to reach out. Any questions or comments, I'd be happy to answer those.